Now, let us take the case of sodium. The atomic number of sodium is 11. Atomic mass is 23, because neutrons are 12 and electrons and protons are 11. So, how will be they arranged? First shell will have 2, K will have 2 electrons, okay. L will have 8, and what is left for M? Only 1 electron. So, it is not satisfied, because the outermost orbit must have 8 or 2. So, this is not satisfied. So, whenever anybody is not satisfied, even a small child, when it is not satisfied, it is cranky all the time, it is crying all the time. Now, you understand why sodium is so reactive? Okay. Now, let us take another case. This is a metal, let us take a non-metal, say chlorine. Now, in case of chlorine, what we find is that the atomic number is 17. So, K orbit will have 2, L orbit will have 8, but M orbit will have 7. Now, even this is not satisfied. So, chlorine is also reactive. Chlorine wants 1 electron, sodium also has 1 extra electron. What to do? Now, one way could be that sodium gains 7 electrons and completes itself, but to be able to take 7, it will require lot of energy. Moreover, the number of proton is same, that is 11. How will 11 protons cope with 17 electrons? Rather, it will become 18 electrons, not possible. But what is easier? That it loses 1 electron, that can be managed. Similarly, in this case, if it loses 7, lot of energy is required, but gaining 1 is okay, within the reach. So, what happens? This one goes here. So, sodium and chlorine can combine with each other and form sodium chloride. Now, how this happens? When it loses 1 electron, it becomes positive ion, anion. Why? Because the number of protons are 11 still, but the electrons are 10. So, 10 cancels 10 and 1 is still left. So, it is positive. But in the case of chlorine, because it gained 1 electron, so the electron number became 18, but the protons are 17. So, it is negatively charged. Now, they have become best of the friends, because one needed to give 1, another wanted to take. So, it is a relationship of give and take. Such compounds are called ionic compounds, and their bond is called electrovalent. You also like those friends who sometimes help you and sometimes you help them. Will you like a friend who is all the time only asking help? Probably no. So, here also what we find is that those elements which have a give and take relationship develop a stronger bond, the electrovalent bond. This is also possible in those elements which require more than 1 electron. For example, let us take the case of calcium. Calcium, the atomic number is 12. So, the configuration will be 2, 8, 2. Now, there are 2 electrons which can be given away. So, if it is in the contact of chlorine, then 1 atom of chlorine cannot satisfy this, because 1 electron it will take. What about the second one? Which means it will require 2 chlorine atoms. So, one will come here and one will come here, and what we will have is calcium chloride. Similarly, with aluminum, it will be 3, because the atomic number of aluminum is 13. So, it can give 3 electrons. So, it will need 3 chlorine atoms to form aluminum chloride. Now, on this basis, we can clearly understand why ionic compounds show certain kind of properties. So, let us see what are the chemical properties of an ionic compound. First of all, the ionic compounds are somewhat hard, brittle, and they are solids. Why so? Because their bond is very strong. So, strong bond, so they are solids, they can break up into small particles and the surface is hard. Secondly, they have high melting point and boiling point. Why? Because to break their bond, lot of energy is required. Now, imagine if in your class there are two friends who are best of the friends and you want to break their friendship. Of course, not a very healthy thing, but say you want to, you will require lot of effort. Otherwise, they trust each other so much, they will never listen to you. So, that requires lot of effort. Here also, it requires lot of energy, so high melting point and high boiling point. Thirdly, these compounds are soluble in water and not in organic solvents like petrol. Or kerosene oil. Fourthly, in the molten state or in the solution form, the electric current can pass through it. Why? Because actually a sodium chloride or an ionic compound is only an aggregate of ions. So, the moment electric current moves, these ions start moving. Now, the positively charged ions will go to the negative charge and the negative will go to the positive. So, in the case of say sodium chloride, sodium will go to cathode and chlorine will go to anode. Because the charged particles always move towards the opposite charge.